that you guys wanted to see? So if I use the head of that, this is what's going to happen. It shows you two things. This is a totally different type of format, but essentially you can think of it as kind of a factor. So it's a labeled number. So we see 1, 1, 1, 1, 1, and then we see the associated labels with it. That's what happens when we print it out. If I said this, I can say tail instead of the head. Tail shows you the bottom. Happens to be like that. Now, not very helpful. If we do the table of it, this is the frequency table. Doesn't give us the labels. So in the documentation in the Haven package, it says, hey, read your data in using like reads data, but you should use this function as underscore factor. This is a function from the Haven package. So I'm going to make a new, I'm just going to convert it. So this is what's going, XX, right? Again, when I'm doing stuff on the fly, my variable names are not really that great. So XX has the converted data. And if you do the head of that and the table of that, it has now converted them into proper factors in R. So by default, when you read it in, it'll give you the numbers that you had in this data with the labels. That is not the way I recommend to work with that data in R. This is the way. So you use as underscore factor, and then you work with these as if they were proper factors. Or not as if, they are proper factors. They have them, you'll notice, yes, they're in order. That Stata had them, right? So it didn't do them in alphabetical order. It kept the ordering in which it was given. So good. And then if you look at them, these are the levels. And if you do the frequency tables now, after they've been converted to factors, you see a frequency table that's much more useful rather than 1 to 6. Okay? So that's somewhere on the website. I'll double check. I'll make it bigger. So you can say like this is the that script is somewhere on there. Yes.
So if you're referring to that variable HB024, can you use the name and either the name or its level? Or is it just equals to 1 or can you say equals to 1?
So in this way?
Yeah.
So some XX HB. So that right there is the reason I like factors in R over labeled variables in Stata. It's because otherwise you have to know that is like the first, right? But if I want to know what I want to know how many fall into that category, or I want to filter the data based on that, I can do that just like it was a character. So I can specify. I mean, it has to match 1 to 1. You can't. You can still do pattern matching and stuff like that we'll talk about. But pretty much, if you want to do filtering, right, or you want to do some sort of subsetting, some sort of thing that says which ones are this level, you can just use the level name rather than having to remember which number it is. Yeah.
Do you know in Stata we use a lot num label comma add, and it sticks so this would be like 1 dot chi 2 dot sig. Is there a way to put them in the same
So why?
object?
So why do you do that?
Like if you were trying to see label and number at the same time, maybe recoding, or if you were trying to match data sets and one was coded at 9s and then you wanted to convert those to missing 0.
So you can do that. I'm saying this would be after you've already converted this stuff in from the factors. So using XX, that's what I'm saying, using the converted data. So if you do as.numeric on a factor, what that will give you back is the index for the level. So for example, this is the data set that we've already converted into factors. Right? We just showed that. If we say as.numeric on that, it's going to say, okay, this is displayed as KAYES, and if I do as.numeric, it's going to say, okay, this one, it's level 1. I'm going to put a 1. At the end, at the tail of it, it's different, right? So let's say, right? So that is a way, if you want to go back to So it's that is not guaranteed to match what Stata had in. Does that make sense? That's not, so that will give you that, so when you say as.numeric on a factor, it's going to give whatever was level 1, whatever that string was, we're going to find all those, assign that to the number 1, look for the second level, assign it to level 2, 3, 4, 5, 6. If for some reason the way you labeled it in Stata was like 1 was this, 4 was this, 6 was this, and in your Stata data set it was 1, 4, 6. It's not, that's not what this is going to do. If you do it that way, because there was only 3 levels, it'll only be 1, 2, 3. All right, not 1, 4, 6. You could technically do it that way. Yeah.
Does that happen at the as factor step, or is that as numeric step?
The as.numeric step does the 1, 2, 3.
So it starts at 1 and it goes into like runs out
Correct.
different categories.
So this as.numeric stuff has no idea with respect to what the Stata was.
Or any diagnosis?
Yeah, I mean, for others or.
But you've labeled them.
Yeah.
You labeled them. So there's usually not an issue there.
Yeah,
Sure.
yeah.
So, sorry, can I just
Yeah.
So if you go back to XX
Yep.
and head whatever that head was, or when you did that,
This or
those levels are numbered 1 to 6, or how they were in the Stata.
so this one is equivalent, but like if this was like 1, 4, 6, 8, after you've converted to a factor, the original numeric values from Stata are gone.
At that line 7.
Yes. They're not gone, but they are no longer, in some respects, relevant.
Are they gone at just the read-in stage? Step line 4?
No, because X has the specific. I don't know this data that well, and I don't know because this data especially is very structured. I imagine the first level is like 1 or 0 or something like that. It doesn't necessarily jump in like level 1. There is, if you have anyone that knows like what one of the variables of these data sets that has like a 9 or a 9, you can tell me that one, and I can do that. But if it's labeled something, so let me see something. Sapply X.
Missing would be 9, 9. Missing, 9 or 9, 9. And don't know is 8 or 8.
In like what, like, but do you know a variable that has that in these data, like HV10 or?
Maybe in the V's. I can't remember what the HVs are right now.
All right, give me 1 second.
So
Yeah.
HV160 has like a 0, a 1, and a 7.
HV160.
Oh, sorry, I'm in the
Yeah. So that's a good question. So we can do that with X and XX. You can do that. That's what I'm saying. It is taking the 2 data sets separately, and then because in this data set, this one has the numbers with respect to the original Stata. This one now has it with the factor. So what I'm saying we could do, we're going to talk about this command in a minute. HVX HV 0.2 period XX HV 24 like that.
That was Emily's question before, right?
Yes.
Yeah.
So you can do that. I'm still unclear as to
They're just other strings, though, right? They're not.
Yeah, it's not a label. I think what Emily was saying is, or that.
We don't do.
Yeah.
Yeah.
There are
Yes.
sometimes where you want to look at both the number and the label at the same time for like.
But the labels are kind of labeled factors don't exist in R because they're not. They're actually more of a nuisance in my opinion in Stata. Right? I agree that if they are, because let's say you have 2 data sets and they coded them completely different, as long as they labeled them the same, then after you convert them, you're fine. That being said, if you have different labels over the years, that is a problem. But if you had different labels, I wouldn't even be sure that the same number meant the same thing across data sets. Like 5 doesn't mean the same thing if the labels weren't the same.
So
Right.
like in DHS, one thing is they, across country, like in different countries,
Yeah.
first level facilities may have different names. So in one country it may be called a health post, in another country a health center.
Yep.
So the labels change, but the number stays the same because they're all referring to first level public facilities.
So you can use, so yes, so it's kind of an interesting question and kind of a mixed bag because you could technically, so X and XX line up 1-to-1, right? They're the exact same data, just the input, the information in some of the columns that were factors are changed. So you can mix and say like, I want these variables from X and these variables from XX, and then you can just bind them together. So I breezed over it yesterday. There is a command called cbind, which is a powerful yet dangerous command, as everything is, which allows you to just put them both in the same data set. That is a okay thing if that's what you're doing, right? But when you're trying to merge stuff and that kind of stuff, there are other merge commands we'll get to, right? So this is a good command, but you are 100% sure that the rows are supposed to line up exactly. In this case, we do know that. We do know that they're going to line up 100%, right? So does that kind of answer some of the questions? So you can paste them together, right? Even though in this case, we are pasting together 2 vectors from different data sets, right? So we took this data set, which had the 1s and the 1 to 6s, and this one, which has that. So yeah, that's one way you can do it. You could also make kind of you can merge these together and have kind of like a super data set where you have a duplicate of every single column. That's not usually what you want either. That's kind of the reason we have factors to get rid of that. But yeah, so you can.
Just did you go over the paste?
No, that's what I'm coming to, and that's in data cleaning. But to answer the specific question, I jumped to that.
Sorry, can I
Yeah.
ask one more?
Yeah.
We use factors a lot, or we use categorical variables.
Absolutely.
So we do a lot of variable generation using categorical variables and writing like really complex logical statements.
Mhm.
Do you have to, if you're using a factor variable, do you have to write out the labels every time, or is there, or I guess the factor levels, is there any shorthand, I mean, so that's one of the advantages of having the numerical values is you don't have to type out the full label every time you're referring to the variable. I don't know if that makes sense. So we might, like in state it might be like replace, x equals 1 if this variable takes on one of these 5 values and this variable takes on, one of these other 3 values and, or whatever.
A lot of like collapsing group 2 and 3 into a single group.
Yeah.
So in your previous thing, you subsetted if something equals k's in the bracket.
Yep.
If you just replace that with the value rather than the level,
Doesn't work.
So that's kind of what you were getting, right? Can
Yeah.
you just use the value rather than the level?
So there is no value.
There is no numerical number.
Yeah.
You could do that.
Oh,
You
I
can
see.
do that, but that's a little bit more dangerous, right? Or not dangerous. You could say like which ones equals. So I said something like this before.
Yeah, that.
You can say which to me is a more
Converting it to a numeric.
yes.
Yeah.
But that's a more dangerous thing because, like, let's say somebody recoded yesterday and we're like, I like this as the baseline category. That'll give you a totally different number.
Yeah.
Whereas this gives you the same thing no matter what, right? Yeah. So, it's just a kind of level of comfort, but yeah.
And it's always basically just alphanumeric order, right?
Default, no. So we're going to change that. So the ones we have aren't alphanumeric, right? So used to represent categorical data. In read underscore CSV, more or less nothing is read in as a factor. Haven does other stuff with stated data sets, but read underscore CSV does not. Read.csv, the base function that we're not using, some of that does. Okay, so the function factor is used to make a factor. These are the arguments. X is the vector that you put in. Levels. Levels is how you can specify the ordering of your data. And on top of that, you can specify labels. Okay, so these three arguments together. So X, if you just put that in, it's going to make a factor with alphanumeric. Okay? Based on whatever, find the unique data, sort it alphanumerically, and then say, that's the levels that you want. All right? If you specify the levels explicitly, which I recommend you do, then it'll put it in the order that you specified. That being said, so you can have, 100 levels, not all of them have to be filled, it's totally fine. But if you have data in X that is not in the corresponding levels, that will give you a missing for that value. So let's say boy, girl, I think it was boy, girl. And then, just your data, you got some new data in, and it was boys, girls, and dogs, right? And you said the levels are boy, girl, but then you had a dog in here, like the word dog. That's going to be missing unless you explicitly set that as a level, right? So levels can be more encompassing than the data. Totally fine. A lot of times you want to maybe put the levels as like yes, no, don't know. And if you don't have any don't knows, that'll still be fine. It'll still be a level in that factor. But if you have yes, no, don't knows here, and you say the levels are yes and no only, don't knows will automatically be converted to missing. Okay? So you just have, that sounds a bit more cumbersome than it really is, for the most part. And I'll get to kind of why and how. And then labels. So levels will go into this vector and like match things, right? So like whatever you say is level 1, it's going to be like, oh, we're going to assign this to level 1, so on and so forth. But let's say in some respects, these are the levels and you want to match here, but you want to label them something else. So let's say, for example, instead of I guess it was K's. I don't know what those other words, what those other things were. But let's say but you wanted to label them 1 dot, 2 dot, 3 dot. So you give it a vector of the things we just described, but the labels would be 1 dot that thing, 2 dot that thing, 3 dot that thing. Okay, and that'd be a way to get. But these match 1 to 1, right? So the first element of this vector represents the first label, second label. Okay. So we'll get to specifying those levels. So I did this and as a quick aside, but it is really relevant, and it's necessary for the lab. So percent and percent. This is the equivalent of in list in Stata. Okay. So like we said before, you were asking, what if I wanted to do labels greater than 4? You wouldn't necessarily do that here. You'd say labels percent and percent. Level 3, level 4, level 5. So let's say you're 0, 2, 2, 3, 4, right? You say, I want to get trues for if x is 0 or if x is 2. Totally fine, not a big deal to write something like that when you only have 2 things. But when you start having like, I want x to be 2, 3, 5, 7, 9, 147, right? Writing those ors over and over and over again is not efficient and it's cumbersome, usually leads to errors. Percent and percent does that for you. So you say x. So the thing on the left is the thing you're passing in. You will get a logical vector of trues and falses as long as whatever you put in on the left-hand side. So if x is length 100, you'll get a logical trues and falses, 100 of them back. X is length 2, you'll get 2 back. If x is 1,000,000, you'll get 1,000,000 back. And then the thing on the right-hand side is the lookup table you're checking against, the list you're checking, right? So if you want to say, are any of these values of x in the values 0 or 2? And again, it comes up true or false. It gives you it's the exact same thing as this up here. Missing data is treated a little bit differently. We will get to that later. But percent and percent, you say, I want to match this against this kind of table, this lookup table, for example, and it gives you trues or falses. This is really, really important for filtering. Okay? Lab. These are all good questions. I have not done so much with the Haven package, but I imagined this was going to be some of the issues coming up. But yeah, so just keep coming with them. Hopefully I have some of the answers. And so we're doing data classes lab. I'll make sure. So that DHS, that file that I had up here, the script should be on the website. It's under, if you just like on the website, if you just look for DHS, it says this is the example script for reading in Stata DHS data. Right, so that's what I just set up there. Oh, and really quickly, lastly, especially for reading in data from Stata, I will figure out how you get this information out. But if you do view on this data, you will notice that it does have the variable labels on the top, right? So household, sample, weight, right? That kind of stuff. And there are ways to search based on that. I just haven't done that. But I'm saying if you did variable labels in Stata, they should carry over. I just want to go over the first two really briefly, because I want to talk about this dput function. So, okay, the first one's relatively straightforward, right? You sort and unique to get the unique values from type. So again, the data is loaded in, we just say bike type. Right. If we plot that out, we see these are the sorted values. So bike boulevard, bike lane, all that kind of stuff. And we're supposed to say that equals b types. And then we run this weird command called dput. So dput is super useful, especially when you're going to post to forums like Stack Overflow and say, I don't know what's going on here. I need help. Dput allow when you pass an object in there, it gives you essentially the R code necessary to generate that object. Okay? So this is not, it's not printed out like it normally was with the bracket and all that kind of stuff. This is something you can copy directly and paste it right back into R. Right? So dput's really helpful for that. So for example, when you're asking for help on maybe a data set or like I plotted this data and you can maybe share like just a brief like top, the first 5 or 6 records, you can put that into an object, you can put dput, and you can copy and paste that into like Stack Overflow or some of these other websites, and then someone has essentially the exact same data that you have, or if you generated random data, and you're like, hey, this is the data I'm working with, I tried this plot, it didn't really work, can you help me out? Dput's a really good thing to allow you to do that. Moreover, I use it a lot of times when I'm doing kind of dynamic or I'll call it defensive programming or factoring. And what I mean by that is if I read in a data set and I say okay, these are the values I got, I clean the data, and these are the unique things at the time. If new stuff comes up, I want you to let me know. So for example, if a new data set came in, I can say, are all the types percent in these values? And if they're not, I can set a flag that says stop the program or send me a warning or, print them out, something like that. So that's a good way to say like, okay, these are the unique values. I'm going to make a factor based on this. But let's say also you want to make a factor. You want to specify the levels like we're doing later, but you don't want them to be in this order. It's a good shortcut way to say, okay, I don't want to copy and paste like level, this. So that's what dput's really good for. And that's why I use it and said reorder them. So you could just take this, copy this over to your R script. And now it's saying, okay, reorder the output of the dput command. So side path is first. So it says, okay, I'm just going to copy and paste. I want everything to be the exact same, but I want side path to be first. And I'm going to call that B types. Okay? So dput allows you to, if you got something as an output in R, it allows you to kind of deconstruct it so that you could recreate it with code. And that's really useful, in my opinion, for getting the levels of a factor, for example. So now we have B types to be this. Now, if we recode type as a factor using this level, and we're going to use mutate in this case. So I'm going to say bike mutate type equals factor type, and then levels equals B types. Right, if I reassign this, and then run head and all that fun stuff, and I'll bring out the output here. If I run head, I have to reassign it. Right? 2 things we should note. What's the first level? Side path, because that's what we passed in. Right? When we do table, side path is the first one because this is a factor. That's the way it goes. That's the order it gives it. So if you've noticed, if we do table on a character, by default it will do the alphanumeric kind of sorting, I believe, because I think it coerces it into a factor. But here's an example. Said, okay, I would like to make this thing into a factor, I don't want to have the default levels. This is how you pass it. And dput allowed us to get a vector that we didn't have to remember all of them or copy and paste them over. It gave us something that was really nice that we copied over, changed the order of the things we wanted. We could have done that programmatically, but sometimes it is better to do it explicitly where you actually write everything out. Yes?
Whenever you change the class factor in this case, you have to always reassign it.
Well, you have to reassign if you want something to overwrite the old data frame, right?
So you don't have to. You can just say bike and then piping.
But piping on its own doesn't do anything.
I know
Right?
that.
Yeah, it'll just print it out. So yes, so in order to keep that change, we did. We could have, but if we wanted to do something, for example, just to bike type, we could have said something like this, right? That will, they'll do the exact same thing. One is just kind of a different way. Like, whatever makes more sense to you in that respects. But if you're used to kind of using mutate over and over again, yeah, you have to reassign. And you can't just leave this off, right? You have to say type equals this. You're resetting that column. So in a similar way, you're also reassigning type. Okay. So we'll go through 3, 4, 5 in about a minute, 2 minutes. So okay, if we want to do, we're doing the exact same thing here. The only difference is we're making a new column type 2, right? But we are giving it a specified number of levels. But that number of levels does not encapsulate all the unique values in bike type. So when we run this, right? So I'm going to show a brief table of bike type 2. Okay. And I'm going to use NA. Actually, let's do this one and use NA equals. Okay, so this is the first one is the original type. The second one is type 2 when we used a subset of the levels, and we note that the number of NAs goes up significantly, or we pretty much encode anything that weren't in those 3 levels into missing. So again, if you specify the levels and those levels don't encapsulate everything, the things that aren't in that set of levels will be turned to NA. Sometimes that's what you want, sometimes it's not. Right? So let's say, for example, you had 9, 99, 999, for example, is stuff that you all wanted the course to be missing. If you didn't put missing as a label in there, they're all turned to NAs. Sometimes it's useful, sometimes it's not what you want to do. So number 4, we do pretty much the exact same thing, or not the exact same thing, we're just coercing things around. So date installed is encoded as an integer. It's 2004 through I think 2012 or something like that. A few dates in there have the value date installed equals 0. We'll talk about if else today to how to kind of change that around. But as that character is a way to coerce something into a character. So we're going to reassign bike, we're going to mutate, and then use as that character. And again, if we use head on that data, we note there are NAs, but now the years are quoted, right, as to indicate that they are a character. Okay? So now we have this as a character. Let's say we want to make it into a factor. We can do that just using factor again. It's going to be alphanumeric. And again, it prints out a little bit differently. So 2010, all that kind of stuff. 2006 is the first level, 2007, 2008. Again, because they're in alphanumeric order. That's the reason it was coursed that way. And now that kind of all is a lead up into this last thing, but we already kind of took the punch out of it. We already talked about what happens when you say as that numeric on a factor. Even though these levels are all numbers, right? The levels are 2010, 2006, 2012, all that kind of stuff. Even though that's the case, when you say as that numeric on a factor, that will give you a numeric vector back, but it will give you an index of which level that record was. So again, although these labels are numbers, right? R doesn't see them as such when you say as that numeric. So if you have a vector that is encoded as a factor, and you're like, that's not correct, I want to get the actual numbers from there. Like you want this to be converted back to 2010. Let's say your data was bred in like this, and you want to get it back to 2010. The way you do that is you first coerce it into a character, then coerce it into a numeric. So going from factors to numerics will by default just give you an index of which level it was. But if you want to say, no, that's not what I want to do. I want to extract 2007. That's what I want. I want the number label. So you have to convert it into a character, right? So then it's like it was before. It's like it was up here. And then when you say as that numeric on that, then it grabs the numbers out of it. Okay? And this is that's just the way you do it, I'll say. A lot of people, that's the recommended way. Right? But this is really important because if you say as that numeric on that and you're expecting to get 2010 back, you're not. Okay? Yes?
If there is not the missing value NA in the first case, you should have the same result.
We should have the same result.
By using the move command. If there was not a NA in the data set.
Yes, if there's no NAs in the data set.
You should have the same output.
These will have, they will not have the same output because up here it's a character, down here it's a factor. So they print differently. It'll still have a vector with that information in there, but it won't present the same way because this is the way characters are printed, this is the way factors are printed, specifying, showing you the levels. Okay? All right, do those steps make sense? So when you want to make something a factor, you reassign it, kind of like we did to mutate. If you want to make it into a character, as that character. And if something's a character you want to make into numeric, you say as that numeric. But this very specific case, if you want to go from factors to numerics, and those factors the labels are really what you want to get at and turn them into numbers, this is the way you do it.
Sorry.
Yes?
Did you do anything explicit to make the zeros an A?
I may have I may have actually run another, maybe accidentally run another command I had in here that turns zeros to NAs. So otherwise they shouldn't be NAs. They might be zeros in your data set. Yeah, sorry about that. I think I may have done that in my lab, like on somewhere farther up. But yeah, those should be in your data set. Will probably be zeros. Right. All right. Yeah. Do you have a?
Yeah, I want to ask a question about the dates. Some data come with the dates specified as a character.
Yes.
Like days, month, and years.
Yes. That'll be at the end of this. That'll be at the end of this. All right. So, all right, we got factors going on. Factor functions the way you do it. There is a levels function, kind of like there's a comments function. Levels is a perfectly fine function if you want to see the levels of a factor. Totally fine. So you say, what are the levels of this factor? You say levels on that factor, it tells you. Levels should not be used to change the levels of a factor. Okay? You can do that. It is very, very dangerous. What I'm saying is, this is the typical case. This is like, Duke Saga 101, right? Case control. By default, what's first? It's going to be case. Right? Alphanumeric. Doesn't know anything about epidemiology. Doesn't care. Okay? So CC is cases and controls. You can redefine the levels using this levels command. Saying these are the new levels. That is not a good way to do it. The way you do that was with the factor command again, and you pass in levels. You can say factor on a factor and respecify the levels. That is okay. But watch what happens when we did this. We said, no, the levels are control and case. It does not do what you think it does. It doesn't say, okay, case control flip. It flips the actual labels. So don't do this. But if you want to say, what are the labels? That's fine. That is fine. Just accessing them. So again, the way you would do it is you just say factor and then specify the levels again. And that works. I have no idea why it allows you to do that. There are ways to make ordered factors. So I've never used them, but the more and more we've talked similarities to Stata, I believe you could do it where you'd say subset data where like X is less than level 5, and you specify level 5, whatever it is like. Let's say it was high, medium, and low. You could say, I believe, X is greater than low, and get medium and high. I think you could do it that way. I almost never use ordered factors though. But if that's the way you think, I guess that's the use case for using them. Otherwise, I've never really used them. All right. Okay. We talked about all this. You want to get things back to character. You say as that character. It just grabs the labels of the levels. They're all good. Again, if you do as that numeric, it'll give you the index for the level back. Again, wrong way. Don't recode the levels with the levels command. Just make a new factor using the factor command. That's pretty much being dead horse there. So there are some other useful functions. Rep. Rep stands for repeat. So it takes usually two arguments, whatever you want to put in there, and either you say each or times, and they have different behavior. So we said boy, girl. We want each of them 50 times. So what that'll do, take boy 50 times, girl 50 times. Give you a vector of length 100. If you say boy, girl times equals 50, it'll do boy, girl, 50 times. So this goes boy 50 times and girl 50 times. This just repeats this 50 times over and over. Sometimes this is useful when you're making things about characters or making things that you want to repeat. If you want to make, I've used it, for example, if I say, okay, I know a data set. Every single patient should have 5 visits of follow-up. I'm going to make, patient ID and visits 1 through 5 over and over and over again for every single patient ID, and then merge that in to find out who missed follow-up, stuff like that. All right, if else. touch on this very briefly. This is the way you do replacement based on a condition. So, like you were saying, you have really complex statements with respect to, gen variable equals missing, and then replace variable equals 1, large if condition. Okay. So if else takes a test, says if that test is true, what do you want to return? If it's false, what do you want to return? So that is the way you do it. That is the function you will use. So for example, you will say, let's say type equals if else. If the type is equal to side path, recode that as something else. So I will do that here. So okay, bike mutate type 2 equals if else. I'm going to say type 3 actually. So if type is equal to side path, put it bad. Otherwise, just leave it as is. Okay? So if I do, and then I'm going to do select type 3. I'm just going to do head. So that works totally fine, except when you got some factors. So there's if else, and then there is a stricter version in dplyr called if underscore else, which will do the exact same operation, except it ensures, it makes 100% sure that whatever you're getting out for trues and whatever you're getting out for falses have the same data type. So in this case, this is a factor. And it said, all right, we'll put bad in there. But what it actually did was, it took and did, it didn't do it correctly because it did like, it did the level of that factor. So what I'm trying to say is, say as dot character, this will work. So there's if else, and then there's if underscore else. So when you're doing kind of character replacements, when you're doing replacements with strings, you should just be doing that on characters. Because if I do this, for example, if I say type, of course, okay. So it's going to do some weird things. It does some coercion of the factor. It's not a great thing. So if you're doing string replacements, just make sure they're characters and then recode it as a factor. Also, if I do this, gives me a warning. So if you do have a factor and you try to shove a new thing in there that's not part of the levels, it's going to give you a warning and say, hey, this wasn't part of the specification of the levels that you had. I don't know what you want me to do with it. I'm going to make it missing. Okay? Yes?
There's no way to create a standalone factor out of bad, like put as factor around bad?
I believe the recommended way would be convert it to characters, replace the bad ones, refactor it. All right. Where were we? All right. If else is also good for making some sort of categorical variable sometimes based on like if statements. So I'm going to read in the Charm City circulator data. This is circulator data where people get on, get off for purple, green, orange line, and the banner line. So I'm just going to read some of the ridership data here. And there is a column called daily, which is the daily ridership. We're going to say hi rider, if else. If it's greater than 10,000, we're going to call it high. Otherwise, we're going to call it low. Right? And then if we make that into a factor, the level low is the reference. We say head. we get low and high. We do a table of that. So pretty much takes an if statement from this variable and encodes it. We can do if-else statements nested. This will be the way, again, this is the way you do it with the dplyr commands. So this is assigning a new column. Before we were just making objects. This is assigning a new column, doing the exact same thing. If you want to nest them, so you say if circ daily is less than 10,000, it's low. Otherwise, do another if statement. Is it greater than 2,000 or 20,000? Call it high. Otherwise, call it medium. So if you have 15,000, this is a false. It'll go to this. This is a false. It'll go to medium. This is true. If it's 5,000, it'll go to low. If it's 22,000, it'll say false. Go to here. 22,000 true. It'll go to high. You get high, medium, and low. So you can nest statements like that. You can do them in sequence and that kind of stuff, and mutating and so on. Cut is a function that allows you to take continuous variables and cut them into categorical variables. Yes.
Sorry, could you go back a
Yep.
slide? So with this, it does does it do the inner brackets first, the outer brackets first? Because I thought when you did a logical statement before, when we were doing like numeric and
Exactly, it'll go from the inside out.
okay.
That is normally the case, but that's not how this kind of workflow is going. So what it says is it's going to test this condition. If it's going to be true, it'll return that value, right? If it's false, so let's say it's not less than 10,000, it'll go into the next statement. And it goes on to the next statement and says, okay, this is another if statement, and it's going to test it. If it goes to true, it will go to here. There could be another if statement for the false, and so on and so on. You could also do this in sequence, which might be a little bit clearer. Okay. Or in this case, you would do like and, right? If it's greater than this, and it's if it's between 10 and 20,000, you would do something like call it medium. If it's greater than 20,000, yeah. Also, you can initialize a variable to be missing, and then you could have it say like, if this variable is still missing, and this condition, put high. If it's, the way you do equals dot still in stata. So you can still do that kind of same logical operation if that makes sense. You say like initialize just period. You say replace it equal to 0 if this condition and it's missing. Replace it equals 1 if this condition and it's still missing, and so on.
So you can use if, and then it won't go to the next. Then there's no comparison for it to be else. So you can just, how is if different from if else?
So I mean if else.
Oh,
That's
okay.
what I mean. Well, you can do the so you can do it in like the square brackets that we talked about. So like let's say you initialize, so you'd say spike high, and we didn't get this function yet, but spike high, spike length is greater than 200, and whoop. Something like that, and then you can do the next line where it's greater than 100 and it's missing. It'll be like medium, and then you say if it's still missing at this point, call it low. I don't know. It depends on the kind of the way you think about initializing variables and replacing like that. But that's kind of a more stata way of thinking. You initialize a variable to be missing. You replace if, and I mean if is in the brackets here, so it's just a logical statement. Replace those with this condition where the length is greater than 200 and it's missing, call it high. If the length is greater than 100 and it's missing, it'll be medium. So those that were already categorized as high, this will come out false and this won't get replaced and so on. Yes?
I have a question. So sometimes we're creating variables where it's equal to 1, say, but it requires a lot of different, if and statements.
Mhm.
Do you always have to reference the data frame each time and then $sign variable for all of them, or is there a way of saying upfront that it's all they're all from this one data frame?
There is a command. There is a command called with, but the way you would do it if you're doing it within dplyr, you use if else.
But you always have to say.
No, I mean
$sign.
not in here. In this way, this is a different way, right? But if you're saying like mutate, right? So if I say bike high equals NA, mutate high equals if else. If that's the case, right, make it, what do we say, high. Otherwise, just keep it as is. That's a bad example. So like, I'm just gonna show you that column. Select length. So you see what I'm saying? So you don't have to do what I just said. So you don't have to do the $signs and all that kind of stuff in mutate, right? But if else, this is doing the exact same thing as before. It's checking this condition. It's replacing it with high, right? Otherwise, if that condition isn't met, just keep it high as is. And, right, so that is the equivalent of the first statement I made up here, right? Does that make sense? So then you can do, I just wanted to go to the next line. I'm going to do this over here so we can actually see it. Okay, high is this. I made it to be missing first, and then it's like, okay. So that is the way you do it in dplyr. You say, run this statement, or that is one way you do it in dplyr. Right? Is it greater than 200 and it's missing? Make it high. If it's greater than 100 and it's missing, make it medium. Otherwise, if that condition isn't met, just keep it as it is. So you don't have to do bike and all that kind of stuff. And you can still do it on multiple lines. So there's no problem in redefining the variable in sequence over and over again in mutate. Okay, so this, at least the data I write, this is probably the most equivalent to replace if. Okay, I'll put that, replace if, and I'll put that somewhere on the website. Okay, yeah.
If then you wanted to assign low equals 1, medium equals 2, and high equals 3, so you have the label and the number.
So why would you? So my question is, why would you want to do that?
Well, easier to type equals 1 versus equals bracket low if you're doing it multiple.
It's easier to do, but it makes the code much harder to read as a person. I mean, I'm just saying, like, for a new person to get that code, it's so my at least for me, I don't do that procedure because I think that's hard to read in code. I mean, I understand if you're the only one using it, but you're saying like you come back in 6 months, like, what is 1?
For us, it's often 1 is yes and 0 is no. So in that case, we just make that a.
So you don't have to do. So if you're just doing 1, 0, and 1, you say like high is length is greater than 200, right? You don't have to do if anything. It's just give me a true. This will give you a logical back, true or false. Right? Or like path type equals side path. That'll give you a logical back as well. Right? Where you can label that again, you can make that something different. But if you want a logical, or or you can say, so I'm saying you could do it like this, or you could say if else this is a side path. Something like that, if you want it as a character.
Can you put within mutate you can have like multiple variables that you're recoding like you're doing here, or is that's allowed?
Nope, that's fine.
Okay.
So you do length on this condition, type on this condition.
So, yeah.
Batching. Yeah.
Between
But if you're doing
Yeah, I guess. I mean, I agree with you. With like equals equals 1 does make sense, or it's quicker to write. But that's just for me. I prefer to be more explicit so I can actually read. Like for me, it's about readability, so I can actually see what I'm doing in the code when I'm looking at it. But again, I work on multiple I work on like totally different projects in a sense. So like I haven't for a long time had one data set where I've worked with really, really extensively. But I do agree when I used to, that stuff was kind of like the back of your hand. So it is. I may be kind of out of touch in that aspect. All right, cut. Ready to cut stuff? Cut. Yes.
So let's say you're reading in a CSV. I think you covered this. You're reading in a CSV. You've got a string, a character column, some random health facility names. At what point does it decide to import it as a character vector versus a factor?
Always character. Read underscore CSV, always a factor. Or always a character. Always a character. Yeah.
So even if you got yes, no, yes, 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 no, 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 yes, no, it'll come as
Yep.
a character.
Yep.
And you'll then have to, correct me if I'm wrong, but there's an option you can flag that things get read in as factors, is that correct?
In read.csv, that is allowed. In my experience, and I would say a lot of people who've used that a long time, that's more harm than good. Because if the data's clean, it's not a big problem.
Sure, right.
Yeah, just but like also like certain things like health facilities, that's fine. But like sometimes like people's addresses, like that shouldn't be automatically a factor. Yeah, stuff like that.
So the good way would just be to explicitly state the columns that you want to change from character into factor.
Yeah, so that's one of my, and then also that spec function I use. You say spec on the data set after you use read underscore CSV. You can copy and manipulate that thing, and then you can say col underscore factor, for example. If you say like, no, I want this to specifically be a factor, you can do that. But by default, I guess the way I'm proposing right now, just incorporate it all as characters, and then do that as factors. I'm also, assuming we're talking about like relatively small data sets where you don't have thousands of variables, because that becomes cumbersome. You can programmatically do it, but we haven't showed you how to do that, how to grossly change a whole bunch of things into factors. But everything kind of goes out the window when we're talking about reading stuff from Stata. Things will become factors and that kind of stuff based on how it's coded in Stata. All right, so cut's really good for making things from continuous variables into factors. So what it does, you take in a vector x, you specify the breaks, and it will cut that thing up and make it into a factor. A lot of times, for example, I want to break this data thing into 10 equally spaced bins. And by equally spaced, I mean the max minus the min divided by 10 equally spaced bins, not deciles necessarily. I'll show you how to make deciles, but that's one way you do it. The most important, other than these two arguments, is include.lowest equals false, which is one of the worst defaults in R, I believe. Because what it will do is if you put in x and you put in the breaks, let's say you have data that's ages, maybe age is a bad example, something a Likert scale, 1 to 5, and then in the breaks you say 1, 3, 4, and then it breaks it out. Include.lowest equals false. What that means is anything that is the lowest break you give it, in this case 1, it will not, by default, include that in any bin. So let me show you what I mean. Okay. All right, so we have this data, we have this ridership. We're going to pass in that vector. We're going to give it some breaks. We're going to go from the min to 10,000, 20,000 to the max. There are 4 breaks, therefore they will make 3 bins, right? I think that's like the pigeonhole principle or something like that, right? So the number of, right? So if you break something with 1, 2, 3, 4, there's actually only 3 pieces you can put things in. So if we did this and didn't put include.lowest equals true, any of the values in the daily ridership that are equal to the minimum will get coded as missing. And that's just by the way it's kind of set up. And you can also pass in the labels. So what it will do, let me show you what it will do with, So if you don't specify the labels, and you just, so here we're just taking numbers from 1 to 100, and we're giving breaks of 0, 10, 25, 50, 100. If you don't specify the labels, this is the way it shows you the data. So back way back when you did math and it was like a line, you had a line and did line segments. Parentheses mean non-inclusive, brackets mean inclusive. So this means it contains values 0 to 10, 10 inclusive, 0 not inclusive. Okay? So a value, if the value of x was equal to 0, it's not in this bin. So when you say include.lowest equals true, all that does is it takes the minimum break and the first level you give it and says include that in there. So let me show you. Give us back. Where are you? Okay. All right. We're going to have to move along quite a bit. These are all good questions. Okay. I'm just going to do this. All right. Cut the data. So head, rider levels 2. That's how it breaks them down. 0 to 10,000. Does scientific notation sometimes. But circ daily equals min circ daily. So for those days where it was equal to the minimum, that wasn't coded as anything. See this little parentheses? It's because, sorry, it's parentheses. When there's no ridership, when it was 0, it said, oh, I'm going to throw those out. So that is why you have to use include. Take a message, include.lowest equals true is the way the default should be. So now, when we set include.lowest equals true, the big difference here for the first level, that first break is just included into a bin. Again, the reason this is important, sometimes you want to do deciles, right? So if I took this daily data set, I'm just going to call it X for simplicity. Probs, let's go sequence from 0 to 1, 5.1, 10 deciles, right? These are the quantiles, these are the deciles of the data. You've broken the data down into some sort of deciles. The labels are not super, they're explicit, but they're not super helpful maybe with respect to this. So you can now now you've created deciles because we grab the quantiles, we grab the deciles from quantile, and then we pass them in as breaks into cut. We made sure to include the lowest equals true, and that's what we get. Not exactly X-style, but yeah. All right. So we need cut. We got labels. We got breaks. Yep. You showed stuff like that. Again, if you and similarly, if you put in breaks, right, where something is lower than the minimum break, that's going to be dropped off. Right. So remember, this is data just from 1 to 100. Values 1 to 9. If 10 is your first break, they're not going to be coded in any of the bins. Okay? So we're going to go to dates and then we're going to do the lab. All right, dates. The bane of everyone's existence in data management, I feel like. So, especially if you do multinational sites, or allow people to write in dates with free text, which is, I think, a nightmare. All right, so dates exist. We imported the data, and read underscore CSV is actually pretty good. It'll do some guessing on dates, and it does pretty well at guessing. But let's say your data is in there, and it's in string and character format, and you want to say, I want to make this a date. Right, so here, this is the format, 0100, right? 01/02, 2011. I'm going to assume for right now that the data is in month, day, year. That is not always a good assumption, especially when you've a mix of US and multinational sites. That is one of the only reasons I ever got someone in our database to be able to click and click on a calendar. It took me 6 months to convince the data management team that that was necessary rather than letting the docs put them in by hand. And then we had a site roll out from the UK that someone was enrolled, I believe, in May, and they had a follow-up in June. And I said, it says 5/6/2011. Tell me if it's if it's May 6th or June 5th, and if you can tell me which one with 100% certainty, I will give up this argument, and then we finally get calendars. So, dates, more or less, in almost any language, you have to specify in some general way, this is the format. The lovely thing about LubriDate is it does a really good job at guessing, or a smart way of guessing, but you still have to specify the order, but it doesn't necessarily say you have to, oh, everything's slash, or everything's dash, or everything's spaces, all that kind of stuff. Or it's, %B for 3-letter JAN and that kind of stuff. A lot of that stuff's out the window. In a good way. All right, so the LubriDate package, right? Again, from our studio, well-trusted source. So we say cert equals mutate cert, mudate2 equals MDY. This is a function in LubriDate. Month, day, year. Put in that date variable. Boom. This looks a little bit different than that. This is a class in R as a date class. Okay? So when you do things like range, it knows to do the range. It knows the min and the max. Right? It doesn't sort this as a character and say the minimum is we sorted it that way. Range will actually give you the first date and the last date. So the function that was really important is MDY. Okay? There are MDY, DMY, YMD, YDM, all the versions that you can think of. But you do have to specify which one it is. Also, so that is a date. So if you say class on that, it says date. If you have more than a month, day, and a year, if you have hours, minutes, and seconds, it's called this thing called POSIX X classes. Just a different format. It's just a more extended format that allows you to have minutes, seconds, microseconds, so on and so forth. So YMD and YMD underscore HMS. So we have YMD, which is year, month, day. And in this case, I have a data set that's 2014, 02/4, 5 in the morning, at 5:02 in the morning with no seconds. This is 2016, September 24th, and it's at 2 p.m. Very different date formats. YMD underscore HMS says it's year, then month, then day. Usually you have a space, hour, minute, seconds. Parses them both. Standardized format. Okay? Didn't have to know it was slashes. Didn't have to know it was dashes. This does slashes. This does dashes. This doesn't have a 0 in front of it. Totally fine. Now, if you give the wrong format, it'll also tell you some stuff. Warning! All formats failed to parse. No formats found. That's because I did YMD underscore HM. Okay? This has seconds. That's not the right format.
So the function name is the existing order,
Yes.
not what you want it to be.
So you don't, correct. So for the most part, I don't reformat the look of dates in R. That is a thing I only know people to do mostly in Stata, right? That creates it in a standard ISO format. So, you know, percent TD and percent those things, you can reformat it, I believe, but no, this is the format in which you're parsing.
Yeah. It's taking a multitude of formats and it's converting them all to the same one.
Well, a multitude of formats with the same order, let's say. Right? Because these are all year, month, day.
Right. So
Yeah.
a multitude of, prettiness. But there are a few different functions, right?
Yes.
So, but all of those functions all convert that multitude of things into the one
Standardized. Yeah. So MYD. So okay.
Right. Yeah.
It's just all permutations of that, more or less.
Of the existing, your shitty version.
Yep.
Taking it into, and so you just have to find a function that matches your bad.
Yes.
current.
Yes.
Have you ever run into any issues where you have something that looks like a date that it then treats like a date, like a ID variable of 2 numbers?
Like when
dash
you
numbers?
read stuff in Excel and it turns in like September or something like
Or,
that.
yeah, like when you go from this to Excel, or do you have to, does this avoid that problem because you have to specify, because a date is a class?
Yeah. So it will. It's pretty conservative. It won't not.
assume.
It won't assume things are dates. Like Excel does. Like
Always
that
assume.
default's
It's a weird
just
default.
weird. And that being said, if you're reading straight from Excel using Read Excel, depending on how the data is formatted, you might get you might not be able
You
to
might
recover the
assign a
original.
date
You might not
to
be.
Excel.
Yeah. Excel might, like, if you save the data in Excel using that date format, that
Yeah.
even though it was just like you were trying to just say 1-5 and it was like, oh, January 5th, 1974, and you're like, no, you might not necessarily be able to recover that depending how it's encoded in Excel. But for the most part with CSVs, they shouldn't be encoded in any way. They should have the original date. It'll be encoded like that. It won't. I mean, unless it's. It might take a guess, but I highly doubt that with read_CSV, unless you specify. So all the fun ways, and there's accessor functions like year, month, day, week, weekday. You can get it to say Monday, mon, or whatever you want it to say, and extract that. Yes.
This takes care of part of the issue, which is different separation signs, right? But it doesn't take care of the issue of, UK versus US, where month goes before day.
No.
So
No.
if you run into that kind of issues, you have to process them in batches, almost.
You have to do if statements and stuff like that. So what you could do is initialize a class that's an empty thing, right? Something like this. So let's do like some pseudocode here, for example. Let's say if else, right? Let's say we have a date variable. I'll just call this good date. If else, like site equals US, right? You could do something like YMD, or what do we do DM, we do MDY,
Oh, MDY, yes.
MDY, which the longer I work in data, the less I understand why we do that. And then you can do DMY, date otherwise, right? Something like that.
You can do the time zone.
Time zone. It should be specified in there, but if it's not, you can append. Like you could just paste onto the string, like GMT, like that kind of stuff, and then parse it, and then it'll take into account the time zone. Right? Yeah, no, dates are great. Yeah.
Can you perform operations on dates and are like
Absolutely.
with another?
Yep. All right, so see, it's got this weird class, POSIX-CT. So if you see that, it's just like extended dates. That's all you got to know for the most part. All right, so this I'm just using an example. Sys.time will tell you what time it is. So this was compiled on yesterday, today, I don't know. Class, remember, it's this weird CT. As.period is a really important function. I told you there's more different data types out there. We weren't going to cover all of them. Periods are one of them. So you see as.period, 20 units equals minutes. Now you can take that time, add 20 minutes to it. So before, it was 2:15. We added 20 minutes. It's 2:35. So let's say you had a visit, you're just like, when is their visit supposed to be up in like a month? You say at that period 30, units equals days, add it on there. Add 6 months, right? You can start see how you can create a data set that has like follow-up visits or something like that. So as that period is really useful, that's from LubriDate. And we're gonna go through. We'll go through this. I want to jump to the lab. Where was the fun thing I wanted to show you? This. So this is the underscore n for all of this data, people. So it has first, last, nth. So first and last, little underscore n equals 1. Last, little underscore n equals little or underscore big N. Okay? Nth, whatever you want it to be. Third, fourth, fifth record. Okay, so I made those things as dates. I sorted them. I arranged the data. So I said first date equals first, last, third, and then I just printed them out. And we see it's repeated over and over again. This isn't super interesting. This is the first date in the entire data set. This is the last date in the entire data set, but that's what it did. Usually, though, you use that with group by, right? So this, I'm grouping it by day, but you can think of it grouping it by patient, then grabbing the first, the last, the second date. Okay? First visit, second visit. So here, I said first date, last date, third date. And so what this is, this is the first Monday in this data set. This is the first Tuesday. This is the first Wednesday. This is the last Monday. This is the last Tuesday. This is the last Wednesday. This is the third Monday, Tuesday, Wednesday. Great. But what do you usually want to do? The command you're looking for is diff time, which takes differences in time or differences in dates. So what am I doing here? First date. I've already arranged the data, right? I've arranged it by the date, so this is important. Right? You wouldn't just do by in Stata. You have to usually do a sort and then do by or do a by sort. So group by the day. The first date is this. Right? I made this date variable. Diff from first is the difference from the first date. Diff time, you put in time 1 and time 2. Now, although I always think of time 2 minus time 1, diff time does not work like that. It takes time 1 minus time 2. And I mean that time 1, time 2 are the actual argument names. So if you look at help for diff time, I always look at the help for diff time. Like every single time I use it, I've been using it forever. I still look at the help every single time. So it's time 1 minus time 2. So this is saying take the date column, subtract off the first date. And this will do this by day. Okay? So if this was patients, you would say baseline visit, and then you say, this is the date column I care about, follow-up visit times, and I would subtract by the baseline visit. It will give me some ugly-looking thing because the default, I believe, is something like seconds, right? So you don't usually want the number of seconds from the difference in seconds between the two. The units command, you say units for that is equal to days. So you change the unit of these, and now it shows you these are the time differences in days. Units, I guess, is the best analogy I can think of with formatting. %T stuff. So what we did was we sorted the data using a range somewhere in the previous slides. We did group it together. First, grab the first date that by each date, grab the first one, made it a column. Diff time took the column of all our dates minus the one with our first date. Now we have differences from the first visit, let's say, in this case, the first Monday, the first Tuesday, first Wednesday, and then units, change that so it was actually comprehensible, and in days, we could have used months, we could have done weeks, and then we can operate on these things just as like they were, this difference in times, we can operate just as like it's numerics, do histograms of it, all that fun stuff. And once you do data into dates, you can plot data on the x-axis, totally fine. Once it's converted to a date, it works just like you would think it would. All right. We need to go to the lab. And we're falling behind on the syllabus. I'm okay with that, as long as we're still learning the things we need to do. All right, let's go over some of these. I mean, we did. I mean, there's simply some parsing. So convert type back into a character, make it column type 2, replacing the older one, where the type is one of these categories: contraflow, shared bus bike, shower, sign route. Call it other. Use percent, in percent, and else. Make type 2 a factor with level, side path, bike boulevard, bike lane, and other. So one way you can do it, again, we want to mutate the data. We want to convert type back into a character using as.character. If else, type in percent, we say the 4 that we had specified. We'll call that other. Otherwise, keep type exactly the same. Assign that to type 2. We're going to say factor type 2. These are the levels that we want to specify. So again, although I teach dplyr and I think it's really good, I don't necessarily use it for everything because if I know how to do something, I don't necessarily search around on new ways to do it. There are functions in dplyr that I don't use that much. One is recode and the other one's recode factor. So recode factor is the command that's probably pretty interesting. So for example, if we took the data and we took type and we made it into a factor like this, right? I'm making bike 2 here. You take the data, factor type, these are the levels that we had specified like we've done before. You say recode factor type, and then you say, this is the old thing I didn't want. This is the new factor, the new level I want it to become. So contraflow to other, shared bus bike to other, shower to other, sign out to other. And now type 2, even though type was a factor, that's not a problem. These are recoded into a new category. I do not know, by the way, so when you do this, I'll show you the output, and if I do a table of it, it works. It pretty much puts everything we wanted into the other category, but for some reason, and I haven't looked at the documentation as to why, it for some reason makes other the new baseline category. It doesn't put it at the end, it puts it at the front, which I think is a little strange. But recode factor, which we're not gonna, I don't have a slide on, don't go through, is probably something maybe a little bit more amenable to the dplyr kind of framework than if else and so on. For recoding factors up. All right.
That's similar, more similar to this data campaign.
Yeah. So I mean, if you think about it, like factor by default is very similar to encode in Stata. Right? It like does some alphabetical ordering and just puts labels to that, and you play around with that. Okay, so what do we got for the first one? What function did you use? YMD. Okay. I made these non-ambiguous in the sense you'd be able to figure it out. Second one, what do you use? MDY underscore HM. Great. Last one. I said I assume MDY. HMS. Okay. You see the outputs. All those fun things. All right.
I will run the first one, the MDY by Disney.com.
Excuse me?
The one on top, the A.
Yep.
MDY.
Can you try on that?
Yeah.
Give you an NA. It'll give you a miss.
MDY is not Y.
You don't understand?
No.
Because you're saying the first thing you're going to see is a month. This is 2014. So it says, I don't know how to make, that's not a month, right? And the second one, it says D for day and then Y. Similarly, if we say MYD or YMD, sorry. Nope, wrong way. MDY. Right? That doesn't work right because it's saying, yep, year's right, but then it's saying day, and then it's saying month. There's no 14th month. So it says, I don't know how to parse that. Right?
Another question
Yeah.
related to that. The first one, YMD.
Mm-hmm.
I had a data set, I want to split the years and the month. How am I going to do that?
You want to split them?
Yeah. I just want the date, the month and the year.
Okay, so I'm going to call this X. Month X, year X, come on. Day X, W day. So it has accessor functions on the dates. So year will extract the year, month, day will extract the day, month will extract the month, W day for weekday, day of the week, and you can get it in any kind of format you want. And then there's additional arguments on some of these for label and abbreviation. So if I say month, three character month or the entire month, something like that. So you can grab things like that, rather than having to do like string splitting and stuff like that. Especially if you've differently formatted dates and you want to do string splitting on them, they are a nightmare. So I would suggest converting to dates and then do these accessor functions. Okay, and you can paste these things together. All right. All right, so I'm going to blow through these really quickly because we've covered data frames. Right? Data frames, each column can be a different class. Matrix, again, is a little bit different. It has rows and columns, but everything has to be of the same class. But sometimes you might get matrices back. The matrix command is how you can actually create a matrix. I have the numbers 1 to 9. You say matrix, n row equals 3. You specify the number of rows or the number of columns or both. And then the matrix by default will fill column wise, right? So it'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Note, matrices look a little different than the way data frames are printed, right? It's got these weird bracket. You can assign column names, so it'll have column names. But you see, when on a data frame, for example, it'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as the row names. This has this weird bracket notation. And again, we already talked about bracket notation. You can use the same bracket notation that we talked about before to subset matrices. So first row, first column. I want the first row, all the columns, all the rows, first column. Row, column, column. Same exact syntax as it was with data frames that we talked about previously. And again, if you subset only one thing, just like in a data frame, not with the tibble, with the data frame, if you only subset one of them, it gives you back a vector of those values, not another matrix. Again, we talked about these already, tibbles, why they're different, row names don't exist. All right, so the last one we're going to talk about is lists. All right. So the function list allows you to create them. Lists are generic containers that can hold anything. And I mean that in the sense, the first element of this list is a vector of characters, A, B, C, D. The second element of this list is the numbers 1 to 3. The third element of this list is a 5x5 matrix. So it contains 2 different types of vectors and a matrix. It could also contain a data frame, a model, a plot object. So it's just a generic container of things. Okay? So if the elements are named like data frames, you can access those things using the $sign. So my list, letters. So if you said my list $sign letters, you'd be able to grab this off. My list $sign numbers, you'd be able to grab that off. If it does not have a label, in order to extract that element, you have to use double brackets. It's a different syntax. So if they're named, just $signs like you would with data frames, but if they're not, double brackets. Double brackets and the index in which it is. Right? So if you want the third element, double bracket 3. If you do single brackets on lists, right? You want the first element that doesn't extract the element. It returns a list with that first element in it. It's important because if you want to say like this and you want to paste this together, this is not a character vector. This is not a character vector. You have to use the double bracket notation to actually extract the thing. It's a little bit kind of like a shell and a shell and a shell, like those Russian dolls kind of thing. You can have a list inside of a list inside of a list inside of a list. We don't use them that much, but some of the functions, especially when we do string splitting, for example. Let's say you have 3 strings, 3 character strings, and the first one has 2 spaces in it. The second one has 3 spaces in it. The third one has 4 spaces in it. And you want to split them up based on spaces. It will return a list. The first element will have length 2. The third will have length 3. The next one will have length 4. So the reason we bring up lists, even though they might not be as used on your day-to-day starting out, when you use string splitting, they're very, very useful. They're going to come up. So we have to talk about it. So again, if you want to extract exactly the elements, the things out of there, you use double brackets. Again, if you use the dollar signs, if it's named, if you use the double brackets and the name of the element, you can extract that as well. And if you want to extract multiple things, you have to use single brackets. You want to extract multiple elements of the list. Again, that's pretty much what it is for lists. So we're going to move on to data cleaning for about, hopefully, one part of the lab. And then we'll probably pick up the rest tomorrow. Okay. Before I move on, lists, I threw at you really quickly. They're very useful, but they're a little bit confusing, especially coming from, they're even more confusing than anything else because coming from other languages, there's not really a parallel in any capacity, right? Vectors, I can at least say this is like a column in a data set. A model, you understand what I'm kind of saying. A list is kind of this thing that can hold a whole bunch of stuff. So lists are a little confusing starting out, but they can be very powerful things because in a list, you could, for example, have a data set. The model you fit on that data set, an object that contains a plot that you want to use, and you can wrap that whole thing up, give it to someone else, and that list has different things you want to access. You say, I want the plot. Just list $, plot object, stuff like that.
So your workspaces could be encoded as a list.
Yes, your workspace you can think of as a list of just all the things. Also, lists where it has different types of things in it, maybe not be as intuitive, but let's say you have a list of data frames. Data frame 1 has treatment group 0. Data frame 2 has treatment group 1. Data set 3, or the third element is the third treatment group, and so on. And you want to perform the same operations over those things. You can do that. I mean, we've shown you a way to do that with group by, for example. Right? But let's say you want to split your data up into different kind of facets, but still in one container.
So it's a collection of objects, or would you say? Because I've accidentally tried to look at a list like a view thing, and it's hard to interpret because it's like 3L all in a line.
Yeah, it tries. Yeah, I've never tried to view it, but yeah, it's just a generic container that usually sometimes you want to group some stuff together, right? So let's say for a model. Right? A model is a good example because maybe you want a table of coefficients, a covariance matrix that you use, and maybe the design matrix together. Those kind of all make sense together, and then maybe like a string to say this was the call that the person used to make the model. That's kind of how models are stored in R. They all are related, but they don't like line up in like a rectangle in the same way. Yeah, they're general containers. All right. So this lecture is long, and it's probably I think the hardest to teach. Data cleaning is just, I don't know. It's like they say all happy families are alike, but all unhappy families are unhappy in their own way. It's like data cleaning, right? All clean data is alike. Every unclean data set is unclean in its own way. It's quite inventive, I find. Some oddities in data that you wouldn't think to be humanly possible, but they are. Okay, so rule number 1, look at your data. Right? That's why we have viewers. That's why we have checks. That's why we have things that allow you to say, like, oh, this is a character, this is a numeric. Look at it over and over again. I don't have to kind of preach to you guys. I'm sure you look at your data all the time. All right, we had before, is that character, is that numeric, all that kind of stuff. There is a function, is.na, we've talked about. It tests whether something is NA or missing. Okay? really helpful. We talked about negation, right? The exclamation point or the bang. So if you put in a vector x is.na, if that's true, then not is.na is going to be false, right? So it just flips the logicals. There are two other functions, all and any, which sometimes are really helpful. All just will return true if every single element in there is true. Any will return true if there's any trues in there. All will return false if not all of them are true. Any of them will return false is if every single element is false, right? So just literally say it in your mind, and it'll make if you think it makes the most sense, right? Is.na not, so are they not missing? You say all. It says, are the values of x, are they all there? Are they all not missing? Right? And any is.na x. Do we have any missing values, for example, in this vector? These are two simple tests that you want to do on certain columns of your data. Complete.cases is a function. It will return true. It will return a vector of trues as many rows as you have in your data. It says if every value of a row is not missing, then it's complete. That is very, very constringent, especially when you have thousands of variables in the columns. That's a really hard condition to meet. Also, a lot of those columns are not very relevant. So usually if you want to use complete.cases, you should use select to subset the columns that are actually relevant, and then use complete.cases to get a true or false if that row has all non-missing data. So the other two I talked about, NaN, if you ever see it, it means not a number. Usually if you divide 0 by 0, that's what you get. If you divide anything else by 0, right, a positive or a negative number, you're going to get these infinities. Negative or positive infinities. Right, so if you see those in your data, that's what it means. So if you say like max on a ratio that you took, that means you probably divided something by 0, and you got infinity. So there are functions. So is.na, we'll check for NAs. Is.nan, is it NaN? Is.infinite, we'll return true if it's inf. Is.finite returns false for all of those. So it's like if it's NA, NaN, or inf, and you say is.finite, it's going to return false. Anything else, like standard numbers and that kind of stuff, it's going to return true. So is.finite is kind of like a catch-all to say, is this some normal data? All right, so missing data with logicals. Let's say we define a vector x, just 5 elements, but one of those elements is missing. We say x is greater than 2. Well, tell me, does anyone know if that value is greater than 2? Can't tell, because you don't know. It could be 5 or it could be 1. So the answer is, it's still missing. I don't know the answer to that question. So the logical operation returns an NA. Okay? You do not do this. This is not what you do. Doesn't equal NA. That will not do what you think. Yes. It's not the same as theta, right? Equals equals dot, not equals dot. That is a different system. You say not is.na and you negate that. That's how you test if it's NA, if it's missing or not. Okay? This will just give you NA like a bunch of times. Because this to R is like some number. It could be 1, could be a million, could be 5. When you say, is x equal to that? It's like, I can't tell you. It could be anything. So it's like, it's all missing. So if you say x is greater than 2 and it's not missing, so before, this value is NA. Now it's false because we said, is it greater than 2? And it's not missing, right? This and, right? This came up. False for the NA. False logically and anything else is always false. If this so it didn't matter if that whatever this condition was, it was false. And you say this and that, the intersection of something and a false is always false logically. Similarly, if it was like this or something true, again, it doesn't matter. If you get a true and you say or, it didn't matter if that NA was true or false, it's always going to come up true. Again, this is what I'm demonstrating. So similarly, x equals 2 or 0, it's going to say, I don't know. Doesn't know if it's 2 or 0. So the standard logical operations with NAs will return NAs in there. That is not a problem when you're doing filtering in dplyr, except filter will remove any of the cases where that condition returns NA. What filter does, it says find me the trues and give me those back in your data set. NA is not true, so it says, I don't care, get out of here. And again, so sometimes you have to say, and it's not missing. Similarly in Stata, sometimes you say, is x greater than 5, but you have to also say x is less than period, or not equal to period, that kind of stuff. So one of the things. Okay, percent and percent on the other hand, always gives false for NAs. Not true. Sorry. Gives false for NAs rather than NAs back. Okay, so before x equals 0 or 2 returns NA. If we said x percent and percent, is it equal to 0 or 2? That would come up true or false. Or that would come up false. You can do it where you do percent and percent with an NA on the right hand side. That will come up true. That's a weird thing for me to see. But you can do that. It returns a logical saying, is it 0 or 2 or missing? And it will give you trues or falses back. The way I would normally do it, is it 0 or 2? If I wanted to keep the NAs, I would say, or is it missing? This is the way I kind of think about it. This is a little weird to me. Because you can't do x equals NA. That will not do what you want either. Similarly, like x doesn't equal NA gives you all NAs, x equals NAs gives you all NAs. Again, if you do standard operations, doesn't know how to compute them unless there's like one clear defined answer, x plus 2, missing plus 2, missing times 2, you still get NAs back. I'm going to do maybe 5 more minutes and then maybe move to the lab, because some of these we've seen already. Right? Unique. Gives you the unique values of the data set. Table. Table gives you a one-way table X. We already talked about use NA. Table, if you put 2 things in there, it gives you a cross-tab. Okay? Unique. Unique keeps NAs in there. Right? We've shown this before. So if a vector has NAs, it's going to be, and you run unique on it, NA will be a level in there. You run table by default, NAs aren't going to be in there. If you say use NA equals if any, if there are any NAs, there will be a column. If you say use NA if any, and there are no NAs, that won't be there. And if you say use NA equals always, there's always going to be a column for NAs, even if there are 0. Okay. Again, like I said, if there's none in there, that'll be gone. 2 things I just said. All right. One of the things I wanted to say, tables with factors. This is one of the things that I've seen people struggle with in Stata. You say, I want a row of this table, even though that level isn't observed. And I don't think that's easy in Stata. I remember trying to like append things and all that kind of stuff. But anyway, if you have a factor from 0 to 4, or sorry, 0 to 3, but the levels are from 1 to 4. So 1, once we do this, that 0 turns into an NA, because it's not in the levels we specified. And again, you can do factor on a numeric variable. There's no problem with that. So then you say table. I'm going to call it tab. You assign the table out to something. You say tab. So what it'll do, first off, that NA is gone. Or that 0 case is actually an NA, which by default isn't shown. And the level 4 is not observed in the data, so it gives you a tab of 0. Sometimes you want this. Right? C.
Are the levels numeric or character?
They're character.
Right, so if you wanted to do a conditional, you'd have to do equals
So
quotations. One.
R allows a lot of flexibility. You can do equals 1.
It'll coerce it to whatever it's needed.
It'll, yeah. Well, what it will do is it'll coerce that thing, the 1, not the level. It'll coerce that to a character and then do matching. And then, we can subset on the tables where tab greater than 0, this is going to be false, and we just want the parts of the table where there's non-missing data. there's observed data. Crosstabs, put in two vectors, get a table. That's cross-tabulation. You want to use NA equals always. This stuff is super important. Keeping NAs, making empty levels, that kind of stuff later when we do testing on like categorical variables. If you add empty rows and stuff like that, that will affect your test, right? So for example, if you're doing a Fisher's exact test and you pass in this table, it's going to assume it's a 6 by 6 table. Doesn't matter if these are all 0. 6 by 6 table. Okay? So when we go to do testing and you're doing tables, you want to make sure that you're doing it on just the data that you want. That also means when you do categories and stuff like that, it is important that you either have them or not have them depending on the test you'd like to do. Most of the time though, when you're doing a Fisher's exact test, for example, this is the test you do it on. You do the test on this, not the ones with 0 counts in them.
You might have covered this yesterday, but instead there's a quick way to have percentages show there. Is there a quick way to do that?
Yes. So this is a 2 by 2 table, right? So just to be clear, right, this is where x is 2 and 4, and I'm sorry, x is 2, y is 4. There's 2 cases in that, right? So they're right here. So we want to do a marginal table, so not the row or column sums, right? We'll get to proportions in a second. So the margin, like it wasn't applied, 1 is for rows, 2 is for columns. So this is taking the sums over the columns. All right, so if we go back here, 1, 1, 2, 4, 2, 1, 1, 2, 4, 2. Right, so it's taking the columns. So the second is taking the sums over the margins, and this margin happens to be the columns. If we said 1, it would do it across the rows. Prop.table is what you want to do for percentages. Well, technically proportions. So if you don't put any margins in there, it does the global cell means, right? So this represents 40% of the data's here, 20%, all that kind of stuff. All these add to 1. If you put in the margins again, in this case 1, it is doing the rows. So these are the row proportions, and then multiply by 100 to get percentages. Right? So 100% of the data in this row is here, 100% here, 50, 50 here. If I said 2 there, it would be the column percentages. Okay, let's move on to that. So, all right, lastly, there are ways to do it, but there's not just one command that says, like, give me ends, and then put parentheses, and then percents in there. That is not, you usually would do that as like a 2-step procedure. Or what we've shown before with group by, right? You can do tally, right? So what does this procedure do? If this was data, it's grouping it by this variable and this variable, and then counting them off. That's all it's doing. So this is the equivalent of a group by x, where you're grouping by x, y, and then you're running a summarize where you're just counting. Or using tally, which is that shortcut. That's all this is really doing, right? The reason we really like tables, 1, they're presented very well, and 2, the other more important point, when we go to use testing, you can pass in a table and it gives you tests. But if you think of this procedure as a group by, where you're grouping on 2 variables and then counting, then you can start making ends and percentages relatively easily and more straightforward for tabling procedures. And I mean, like, getting them out of R. So we're going to do the first 2 parts and probably wrap up. And then tomorrow, it's the wonderful world of strings and text.
Can you start at 1 tomorrow, or is that?
Yeah.
Can other people start at 1? There were some comments that the pace is pretty quick.
Yes, so you have it recorded.
Yes. So everyone's okay with starting tomorrow at 1 p.m. Is that correct? You have nods. Okay. We have a nod and a.
I might be a few minutes late. But
Okay, that's fine. Oh, so it seemed like the discussion was I'm not sure if people are doing homework. So do you want to go over the homework? If right. So I mean I understand. Yeah, this class is a little bit different. So I mean there is homeworks on there, but if no one's doing them, I don't know if there's that much relevance to kind of go over them step by step, unless you want to just go over another script, kind of and walk through it.
Does anyone have questions about the homework that they'd like to do?
Well praised.
That's a good question.
Some people are taking for
No.
Yeah, someone taking it for credit.
No, that wasn't mine.
No, that was no one is taking it for credit.
Can you tell us, for those of us who haven't done the homework?
Yeah. Uh-huh.
Is there meaning? I assume there's stuff there that you're not covering here. How imperative do you think it is for
Let's
us to
see.
do the homework?
So, I mean, the most part is just like, so this one is about, just more help in this one with respect to summarizing, filtering, doing scatter plots, like just, it's more kind of making you do them.
Right.
And the one thing was like saving things into an RDA, you know.
Okay, so it's reinforcement.
It's reinforcement for homework 2. Homework 3. I think this one's a lot better at reinforcement, for example, because you do get a little bit more plotting, and we'll get to this reshaping data and like turning in from wide to long, but we'll cover all that. It's not like there's anything special or secret in there. Yeah.
Can we say we'll reach out to you if we find time to do the homework after
Yeah.
a few weeks?
At some point.
Let's say August 25th or August 17th. Let's say that's the end because that's the end of Summer Institute.
So the keys are online anyway, right? Right.
Yeah.
Can I ask a question about table? Sorry.
Yeah.
Can you use the same syntax but using like column names? So like you would in Stata, like, tab. X,
Yeah.
or something.
So okay. There is a function called with, which simulates a lot of the same behavior as dplyr. So what did we have? Bike. So that's table bike subtype bike type. Right? This. And you don't like $. You can say with bike. This might be a little bit small. So with saying it pretty much says in similar ways when you say mutate, like I'm using this data set and that's where I'm grabbing these columns from. Yeah.
Thanks.
So that can be used with pretty much any function. I would not recommend using that with the dplyr functions, but with any of the standard functions where it's like I don't like using $signs, right? It's fine. You can just use width, right? So like if I wanted to say mean length with width, so how many complete cases do you have on bike? Do you have a number? I think I heard multiple numbers there. So that's the number of records. Yep, 1631. Who's got, how many complete cases do you have? 257. That's what I got. Okay. So the second question illustrates that is.na will take in an entire data set in. And what it will give you, what class is NA mat? Matrix. Okay. So if I run this, it tells me the number of missing values, right? Similarly, because we said negation, like not missing, I'm going to call it that. That's the number of non-missing values that you'd have. All right, so this will tell you that subtype has 4 missing values, length and date installed, totally complete, even though we already know, because we looked at this data multiple times, date installed equals 0 in some of those cases. And row sums is going to say for each row, add up how many missing values you have. So you can actually append that as a column and say, this is a record with a couple missing data points. So let's say like bike, num missing, row, sums, and a mat. And now we could say like, let's look at bike. Missing is greater than 5. 2. Okay. Let's say maybe 3. Okay. All right. These are the cases where these rows have more than 3 missing values in any of that data. And now, moreover, like we did before, we could have said like bike, select, subtype, block, project, and then run is.na. Right? So we can pipe these 3 together, and that'll give us a matrix with 631 rows, I believe, and then 3 columns. It'll give us a matrix, but it'll be, is it missing or not? Because before, if we just say is.na on the entire thing, it'll go through every single column. Here, it'll only go through the columns we just selected. Right. So if I say head around this whole thing, it just gives us trues and falses if it's missing. And then we can do row sums on that, Yeah, so like, for example, egen row miss, I believe, is the stata equivalent. Right? So row sums and col sums, at least at first glance, I think to a user seem like, why would I ever want to do that? When you want to start counting things like logicals based on some interesting condition, that's when they really start to become pretty powerful. All right. So who can tell me how to filter the rows of bike that are not missing the root variable? So what do we use to subset rows? What dput from? Filter. How do you determine if something's missing? Is that NA? And how do we flip trues to falses? Negation, yeah. All right. There's a good move on. Probably talk about it in 2 or 3 minutes.
Is there a shortcut for the percent and percent?
Percent and percent? No. Yes. Okay, let's go over some of these. All right, so we made this have route variable. And so let's do a table of the subtype using table, including the missing subtype. So somebody give me a quick rundown. Just do table, right? So what's the option that we're gonna make it so that missing values are always shown? And we're gonna set it to. All right. Oop. Okay, so we got 4 missing values there. So let's do group by. Somebody have a group by. So you group it by what? Group it by subtype. And we're just going to run tally. Nope. Pretty much same information, just in a different format. So let's filter the rows that have side path or bike lane. Let's call it side bike, right? And we're going to say bike. What are we going to use? Filter, right, for the rows. And what am I going to do here? Type percent and percent, side path, and bike lane. Filter. It's an n row side bike. All right, we get 628. Let's say we did the same thing. Let's just say how many rows would we get if we filtered it using equals equals or still 628. They're the same. Let's do a cross-tab bike type and the number of lanes. Let's try with, right? Bike. So what's the command? Tables. All right, just do table. Type num lanes, I believe it is. All right. So we can use with here, but like I showed you before, we could have also done like $, like $. Same table. All right, do a prop table on the rows and the column margins. So let's do, I'm going to call this tab, right? That's what we said, prop.table tab 1 and tab 2. When I say 1, what am I doing? What kind of percentages? Row percentages. Right, so everything in the row should add to 100. Column percentages. Right. We're going to say as.data.frame, so we're coercing it to a data frame. We can get something similar to what we had before with respect to group by, variable 1, variable 2. Variable 2 is the number of lanes, and it gives us the frequency. We can also use broom, which we'll talk about a little bit later. And if we want to tidy up a table to get it into a data frame format, that's the way we would do it. All right, really briefly, since you asked, if you really want to do this, I'll put this code online. So if you run this command, right, and so this is to get percent and percent as a keyboard shortcut, if you like. So if you run this, it'll create what's called an add-in. Then you go to modify keyboard shortcuts. And you look for percent and percent. You click the shortcut. You click whatever things your heart desires for that to be the shortcut. Mine would be Command-Shift-I, for example. Then whenever I type Command-Shift-I, percent and percents all day. So you can modify keyboard shortcuts with tools up here. Okay? All right. I think that's all she wrote for today. I thought there was one more thing I wanted to say. I forget now. So I think this is the day usually in the class with the most growing pains. I mean, not because, just because, I mean, the class is fast, obviously, but it's also, you are starting to figure out what you can and can't do right now. But is there anything, I mean, a lot of it's confusing because it's a totally different system. But is there anything that's like flat out, like this makes absolute no sense? Like, I don't know how to, like, I don't know why we're, what filtering rows is doing, what the dplyr functions is doing. I mean, we haven't talked about formula syntax. We haven't talked about anything with modeling yet at all. Like, so not the things we haven't covered, but the things we have covered.
Do you have more examples? Sorry.
Yeah.
Do you have more examples on using the piping function in dplyr and have comparisons between what it looks like without the piping and with the piping? Because I'm having a hard time understanding the piping in the answer keys and the
Okay.
answer type piping.
Yeah. I can put them with the parentheses around it rather than pipe through.
So between the dplyr and the base R, I mean, how fast do things change? I mean, let's say what we're learning today, in how soon it'll, be out of fashion and we'll use that.
Out of fashion, that's a good question. I don't really know. At least I would say.
What has been the record? What has been the history
I mean,
between the dplyr and the base R?
I mean, base R is R, right? So it's
Right,
been
yeah.
around for as long as R has been around. I would say it's still on the upswing. So like you think this is the peak, and then it's going to go away. It's still probably midway through a peak. So I'd say at least 5 years before like dplyr becomes like not obsolete, but
Something else.
yeah, supplanted by something else. But I don't think that's necessarily going to be the case because they're still doing a lot of active development on it. A lot of code relies on it, right? So once that goes down, a lot of other code goes down with it. Do something.
Will it be just subsumed by the base version at some point?
Will they incorporate that? No, I'm gonna close this because